Dear students, coming to the next topic, we will discuss about stress concentration. This is another um, topic which is so frequently asked in the exams. You see, in this subject of machine design, nowadays, you see, almost 50, 60% or so theory questions are asked, 60, 70%. And only some 30 or 40% of numericals are asked. Okay, so numericals also you can practice, become an expert, and these theory questions, these questions, sure shot you can get the marks for these things. Okay, so this is one of the very commonly asked theory question. What is stress concentration? Otherwise, what is stress concentration, and state its effect on the material in case of static loading and cyclic loading. Uh, like this, the questions come. Now, what is stress concentration? You see, when we are designing a machine element or some part we are designing, there are many force stresses acting. There may be many stresses acting. It may be bending moment coming, because of which bending stress will be induced. Then shear stress may be induced because of the twisting moment. Then there may be tensile stresses or compressive stresses. So these, what all equations we are using, what all formulae we are using, these are all developed with this assumption that the material is fully uniform. There are no discontinuities. Discontinuities means, suppose there is somewhere in the middle hole, or the plate, a cracked little. What will happen at that place? Okay, so and suppose there is an abrupt change in the cross section. That means there is a wide cross section for some length, and suddenly the cross section, the width of it changed. It became less, and then there onwards the width is less. Then what will happen at that place where the cross section is changing from a larger width to a smaller width? Then what will happen? Okay, but in you see, these are all theoretical equations, the equations which we are assuming that there are no discontinuities. Discontinuities, this word is important here. Okay, discontinuities in cross section. But when are there are discontinuities in cross section, like keyway. Now at this stage you may not know what is a keyway. Okay, okay, we will come to know about it. A keyway, a threaded holes, grooves, all these things which are present. As I told you, a hole or a crack, a notch, some things, such are things are present. What will happen is, so in the vicinity means in the nearby region. Vicinity means nearby adjoining regions of that discontinuity. The the stress equations no longer describe the state of stress in the component. So the stresses induced in the neighborhood means around the discontinuity of that crack or hole. The stresses induced, or that stresses developed in the nearby regions of that discontinuity, are much higher than the stresses in other parts of the component. And this concentration of high stresses due to discontinuities or abrupt changes of cross section is called as stress concentration. Here what is underlined is the definition of stress concentration. Okay, now let us see a figure. Okay, now there is a plate here which is subjected to some tensile pull P, and there is a hole here. So what will happen? See, when we are pulling it, we can assume that it is as well as, the stresses are some straight lines like this. Stresses are all straight lines. Hmm? It is consisting of many straight lines through the body. But where the hole is made, when the hole is made, so these straight stress lines cannot go straight like this. Now these stress lines will come like this and it will go like this and go straight like this. You see, as suppose in the road traffic is there, many vehicles are coming, and in the middle some pothole or something is there. What will happen? All the traffic will try to go like this. Okay, and the traffic that is coming from this side will try to move like this and go. So there becomes a bottleneck here. Okay, so that in this place there will be a traffic, a very concentration of traffic, where the traffic will become slow. Okay, here you see in this figure, suppose these are the lines of force that are going. Okay, actually here this much should be there, but because the stress lines that are coming here are also coming here, so at this point, at this tip, the stress has risen so much, and a little further away, this is this much. So as you go away from the hole, it will be reducing. As you go towards the hole, it will be increasing, and after certain region it will become normal. Okay, so because of this discontinuity, because of this hole, what has happened is there is a concentration near the hole or discontinuity, and this continuity is called as this stress rise in near the discontinuity is called as stress concentration. That means stress is concentrated. The stress concentration in a rectangular plate with a hole is subject to tensile stress is shown in this figure. Okay. um, okay, coming to the causes of stress concentration. What are the causes of stress concentration? Why stress is concentrated in some places? uh, what are the causes? You see, the causes can be abrupt changes in the cross section. That means cross section suddenly changed. Abrupt means suddenly. Change of cross section is changed, like uh, in this figure, that we have seen just now. See, here the cross section is the, if you take a cross section here, it is, without any hole here. This is a big cross section, whereas here cross section is, you have to minus this hole, so the cross section has reduced. Okay, like that. So abrupt change in cross section is one thing. Then second is poor surface finish on the surface. If it is a smooth surface is there, that means less of stress concentration. If good surface finish is there, if shiny surface finish is there, less concentration. If poor surface finish is there, more stress concentration. Then localized loading. In one place it is loaded, in other places is not loaded. In the loaded place there will be stress concentration. Okay, then variation is material properties. The material property, see, material is not uniformly made. You see, if it is a steel, in all the places, if you go inside and see, there should be iron atoms, carbon atoms, and other atoms like manganese and chromium, nickel, whatever other things are there. If they're evenly distributed, no problem. But suddenly some material is more in one place and some other, and some less in another place, then there will be material properties. Variation will be there in material properties if it is not uniform throughout. Okay, so these are the causes of stress concentration. Okay, and then how next is remedies. How will you reduce the stress concentration? Is the stress concentration good in the first place? Is the traffic concentration on the road good always? No, traffic should be going smoothly. If there is a concentration uh, of traffic in one place, there problems will arise. Similarly, here on the stress concentration also, if there is concentration in the stress in one place, there the crack may initiate, there it may start to fail. So we should try to reduce the stress concentration. Now let us see what are the how we can reduce. What is written here? In the presence of stress concentration cannot be totally eliminated, but it may be reduced to some extent. You see, we cannot fully eliminate it. You see, if nut and bolts are there, you see, for putting nut and bolt, we have to make a hole. That's why many times they say, why do you make nut and bolt? You weld it. Nut and bolt you are making, making hole means you are making the material weak in that place. Weld it. Welding is better than nut and bolt, they say. But in every place we cannot weld it. There are places where we have to use nut and bolts. Nut and bolts have the advantages of dismantling and again assembling. Welding has no such advantage. So everything has its own advantages, disadvantages. So we cannot completely eliminate it. We can only reduce it. Okay. To decrease the stress concentration, the stress lines should maintain their spacing as far as possible. You see, the straight lines mean stress lines means what? The imaginary lines which are going, and I was saying no, like all these lines are going parallel to each other. Those are the stress lines. They should maintain equal spacing as far as possible. Then the change in the cross section should be gradual to the possible extent. Some changes adopted in the design in order to reduce the concentration. Some changes we can use. Okay. The stress concentration can also be reduced by improving surface finish. Surface finish also, if you make the surface very smooth, that means your machining methods should be in such a way that surface is smooth. Then you can reduce. Okay. Now these are the methods that are adopted for reducing the stress concentration. Additional notches and holes in tension member. This may appear strange to you, but you see, this was the hole that was there in this rectangular component. Okay. Now, so what you should do is, you see, instead of this coming straight up to here and then the line going like this, you can make a small holes on the other side like this. Then the lines will go like this. So this line is not as sharp in this place. A sharp turning is not there. A smooth turning is there. So this is one way of reducing. Okay, like additional notches or holes in the tension member, use of multiple notches, drilling additional holes, removing roughness. Okay, so like this here also, shaft with a keyway. Shaft with a keyway. This is the shaft and this is the keyway. Maybe they have added some two more small, drilled some small holes or something like this. Okay, this is one method. Then next is fillet radius, undercutting the notch for member in bending. Fillet radius means what? Says now here abrupt cross section change variation. See, this was wide here and this narrow here. The stress lines are going like this. So at this place, no, there's suddenly the stress is concentrated. So here in this corner, it may crack like this and come. Okay. And for that, how to improve? You see, here no, at the end he has provided a fillet, a fillet here like this, a little curve. Can you see? A little curve is here, a little curve is there. So a little improvement. This was poor, this is better, good. Okay, and this is the preferred. That means here no, a little taper itself. Thereby these stress lines are more smoother without abrupt change. Okay, this is improved stress concentration. Okay, now this is one way, by providing fillets and undercutting. You see, now here a threaded component is there. Reduction, see, this undercutting means, like is this much portion is this material is removed. this much portion material is removed. See here, no, because of these threads cut, the stress concentration is like this. Okay, so now if you undercut a little like this, so the stress line is going like this. But this is poor, this is better, good, that means a better, and this is the best one, that is preferred one. What? Fully the body itself, you turn it. That means what? You turning means on the lathe you turn it and you reduce it, and threaded should be outside. So then these lines will go straight. In threaded, reduction in stress concentration in threaded members by either undercutting or reducing the diameter of the shank to that of the root diameter of the threads. This is the core diameter. There are two diameters here. One is outside diameter and one is the core diameter. Okay, core diameter, if you make this shank equal, then these lines will go straight. Okay, then drilling additional holes for shafts, that they have already told before. These are the methods of reducing the stress concentration. Okay, next, there is something called as theoretical stress concentration factor. You see, what happens is when a discontinuity is there stress will be more. Okay, and away at a distant place from that hole, from that discontinuity, stress will be less. So this theoretical or geometrical stress concentration factor, which is capital K suffix T, is the ratio of maximum stress at the discontinuity to the nominal stress away from the discontinuity. Okay, this is called as the stress concentration factor, theoretical stress concentration factor. Kt is maximum stress upon nominal stress, that is sigma maximum, that is at the discontinuity, and sigma O, that is away from the discontinuity. If it is a shear stress, tau maximum upon tau zero. The theoretical stress concentration factor depends only upon the geometry of the component, and the material has no effect on its value. So material will not do anything, only the geometry this depends upon. Okay, and see, what is this theoretical stress concentration factor? Why are we studying? Actually, it is used in solving the problems of fatigue problems, fatigue stress problems. Okay, uh, are we going to use at this diploma level? I don't think we'll be using it. Okay, will not be using it, but only that, as a theory portion, what is a theoretical stress concentration factor, this much you should know. Okay, now next, again, something called as fatigue stress concentration factor. Fatigue stress concentration factor, and also another thing called as notch sensitivity. Now, in actual loading, especially fatigue loading, I am okay. What is fatigue loading? Okay, this fatigue loading you don't know as of now. Okay, I will teach this after some time when I tell you fatigue loading. Then we will see about what is fatigue stress concentration factor and notch sensitivity. So for today, we'll stop here.